Hi everyone, this is D. Lavanya. This video about buffer overflow attack using the Seeds Lab environment. Here we downloaded the two files and we extracted it. And this is programming run in the terminal of the Ubuntu. A vulnerability that talks very small at the first but has the power to completely break a system if they exploit it correctly. So that let us start from the basics in a very simple and clear way. In a computer programming, a buffer is a temporary storage area in a memory that is used to hold data while it is being processed, such as user input, file data, and every buffer is created with a fixed size, meaning it the only a limited amount of data. But the problems begins when a program does not check how much data is being written into this buffer. A buffer overflow occurs when more data is written into a buffer than it can hold, and this extra data does not just appear. It splits the over locations, overriding the important information such as variables, control data, or a function written addresses. And this is where the real danger begins. This is buffer overflow. Especially in a lower level languages like C and C++, where the programmer has direct access to memory but the language over itself to validate input or uses unsafe functions becomes a vulnerability. To understand this, how buffer overflow actually works internally, how memory is organized in a running program where the memory is divided into segments such as code segment and the data segment. This stack or a heap in stack based buffer overflow. The buffer is stored inside a function on the stack along with the local variables and the return addresses, and it is XOR provides a carefully crafted input that executes the size, and the extra data can override the program's addresses, which tells the program vulnerability go after the function finishes. And an attacker can react the program execution to the malicious code, often called shell code, which can give the attacker complete control over the system. Next, heap-based buffer overflow attacks, on the other hand, occur in the dynamically allocated memory where the overflow and the one heap buffer can override the adjustment objects, leading to the memory cooperation and the potential code execution. Although to exploit, they're still extremely dangerous. One of the reasons buffer overflow is considered so seriously because it can lead to remote the code execution, meaning an attacker sitting anywhere in the world. So we have the root axis. Similarly, for the level 2, the goal is to learn how to succeed when you don't know the exact buffer size. So we will almost apply the logic, but we have no idea of the buffer size. So here we exploit the file buffer, we commit over the start point and the remaining values. Same, and we commit the oversight because we don't know about the buffers. So we will here the successful overcome the level 2, and we can verify it same method. We have the root axis. So for the level 3, primary goals is overcome the null byte consist of 64 bits. So the one of these mostly used is 32 bits. So here we will use the 64 bits. This 32-bit shells code the and start the point would be the 570, which is the exact bytes of files minutes length of the shell code, and we will make some changes in the input. Thank you.